Hello and welcome! So, we are at the infamous zipper problem. Okay, it's not infamous, it's so entertaining. Alright, so we have a plastic cover is made for a cylindrical pool that has a diameter of 22 feet and a height of 10 feet. Alright, let's break this down a little bit. First off, diameter. How does the diameter relate to anything else in a circle? Right? A diameter is going to be twice the radius. So if we want to find the radius of a circle, all we take is the diameter and we half it. So that means if our diameter is 22, half of that is going to be 11. So that means while we're told the diameter is 22, we immediately know that our radius is 11. Okay? And then we're told that we have a height of 10 feet. So that means that we have a cylinder, right? And this is a 10-foot height. Might be useful at the moment, we don't know. Okay, and then from there we have a cover on top of this pool, and it will include a wedge-shaped flap that forms a 29-degree angle at the center of the cover as shown in the figure below. A zipper will go along one side of the wedge-shaped flap and around the arc. Which of the following is closest to the length in feet of the zipper? Okay, so first off, this whole cylindrical pool thing with the 10 feet, that's useless information. Okay, you're trying to find the length of this zipper. Now, does the zipper have anything to do with the height of the pool? No, we're only talking about the surface of the pool. We don't care about how tall it is. That 10 is a distractor number. Don't let it distract you. Okay, great news is that we already know part of the zipper. By finding our radius, we already know that that part of our zipper, this little section right there, we know that is now 11. Huzzah! So the only thing we really have to worry about at this point is what that length is. We're also told a couple of things. The first thing that we're told is that we're told, bam, 29 degrees is the angle forming this arc. And you say, okay, well, how do we find the arc itself? Well, let's use a little bit of our circle common sense to help us out with this thing. So first thing I would say is, okay, that yellow portion, the arc, is on the what we call circumference of the circle, right? Circumference is like perimeter, but for a circle. It's the outside edge of a circle. Now, an arc is a portion of the circumference. Okay, it's just a little section there. Specifically, it's a 29-degree section of your circumference. So how we can find it is we could say, all right, well, circumference of a circle is 2 pi r. Okay, and 2 pi r, where we know our r is 11, we already found that. That's 2 pi times 11, in other words, 22 pi. That means that that entire yellow line is 22 pi. Well, we know that of that 22 pi, we're only taking 29 degrees of it. Okay, and what's the all the way around the circle? What's the whole circle degree measure? 360, right? To go all the way around a circle, it's 360 degrees. That means that if you take your circumference and you multiply it by the amount of circle you have, that's it. This is a percentage, right? You're just taking a certain percentage of the circumference. That's all we're doing here. And that's how we can find our arc length. So then all we do is this is just a little bit of calculator work. Okay, you'll notice that none of your values here have pi, so that means we're going to be multiplying pi in on this one. And this is just plug and chug into some calculators. So let's go into this. So we have 22 pi times our, 29 degrees or 30 degrees? 29 degrees, there we go. Times 29 over 360. Right? You don't have to worry about the degree symbol. It's because when you have a degree over degree, right, these will essentially end up simplifying with each other. They'll cancel out and leave you in the just straight radians. Okay? So then you have 22 pi times 29 over 360, and we're left with 5.567. 00314. All right. Oh golly, I forgot it. 5.568. Okay, so approximately 5.568. There we go. Alrighty. Now, are we done? No, right? We've found this section now to be 5.568. Well, now we're finding the length of the whole zipper. It's not just the 5.568, it's that plus the radius, right? Which means that we do 11 plus that number, so 11 plus 5.568, and we end up with 16.568, which is closest to one of our answers, known as 17. And that is it. That is your correct answer for this particular set of numbers in the question. All right, and that's it. That's as crazy as it gets. It really just boils down to your circumference times the percent of circle that you have. Okay? That is all it takes to solve this problem for the length of arc that you need. Okay, plus whatever the radius, because this thing is the arc length. Okay, not too crazy. Thanks for watching.